So, okay, as I said, I actually like to talk quite a bit, so here I go. So data, I've got this question. This I'll keep for the afternoon, I think. But I can talk a little bit about data. It's true if you do sort of spatial data analysis, you are almost inevitably highly dependent on already existing data, on secondary data, even if you collect your own primary data. And even that is quite rare. Typically, we use existing census or health or other data sources all the way. And there's a lot of data out there, and it's hard to find, and you have problems with formats and all of that. And it was really, really very difficult, maybe up to 10 years ago, and it's quite easy now, relatively speaking. But it can still be a minefield. So I'm not quite sure what to say about it, but one particular question I got about was this get data function in the raster package. It's a bit of an odd thing. My plan is actually to make it a separate package, sort of a data package that would point to all kinds of online resources and would then download it and make it available. The reasons for doing it are sort of twofold. One is just easy. I find it just easier to do this, and then if I want a different country than France, you have to. So here we say the get them data, so there's administrative boundaries. Country is France, the ISO 3 code, 3-letter ISO code. There's a function for that to look them up. First level, FRA1 is that. It takes a little while to download. Not sure if the fifth level is already here. Yeah, there we go. Let's try the fifth level as well. It's just easier than to go to a website, download it, unzip it, put it in a folder. You don't quite remember where. What function do I use again to read it? So because now we have plot FRA1, should have France. I also they called number 5. That's of course number 5. Isn't it lovely? The French commune. Clearly, this is not a data set that's very appropriate for my machine, and R. It takes a little while to draw. But eventually it gets there. Wow. So how many communes are there in France? We'll find out when it stops drawing. I think it's still drawing. Wow. I'm not sure. Maybe I can just. I'm not sure what I did. Oh, it's finished. So FRA1, which was really so 36,000 communes, at least according to this data set. The actual number 1. These are regions, region. You can add those plots, FRA1. That is true. Border is red. Line width is 2. See if you can see that. There we go. So that's nice. That makes it easy. Of course, if you have data for the French departments that you may want to link to this to plot something, you always have a lot of trouble with the spelling. You may have Ron Alps, but without the little hat on the O or without the dash, and so it's always a lot of work to make these things fit. But there's the data certainly for display. You can use them. Yes.
Can you go back to how you got that data? Because I missed it.
Do you have an internet connection?
It says I do.
It says you do. Well, if it says it, so that's so. Oh, okay. So this is the idea. So Sweden, get data, get them. Country is Sweden. Level is 1. This is what it should do. Let me just run up there and see the little comma you've forgotten, or the quote you've forgotten, or something like that. Let's see. Country is unexpected input in. It's odd. So I think you copied it here. This is not the right one. Something like that. So did you copy it from somewhere, from a PDF?
Yeah.
Yeah, if you copy from a PDF, so country is also wrong.
Probably.
So one issue that if you copy from PDFs, often the quotes are not the simple quotes. You get these fancy quotes, and then R doesn't understand them. So careful with that. You get little curly quotes. So this is the administrative boundaries data, and then in the same get data, you can look here. What else you can get? You can get the SRTM elevation data, world clim. Also, the CMAP5 data that I used yesterday is just not documented yet. Right. So yesterday I have that here. I think I did this. A magic number?
Yeah, I think I missed the magic number or something. Give me this error. Battery stop file magic number.
Maybe corrupted. Oh, well, that means that your download was incomplete.
Okay, maybe the internet was.
Yeah, probably, yeah. Because it tries to unzip it, but it cannot, or something like that, or yeah. And so this is one easy way to get data. Obviously, there's only very few data sources. Yeah.
I guess you plan to document it soon, right? To say what it was.
Yeah. So this gets us a bit also to climate data downscaling, and so if you for now, I mean, you can sort of guess it. I mean, you have the hard part. Well, you have CMAP5, a model name, an RCP, and a year, and a resolution. This is like the world clim. You just have to know what model names you can use and what RCPs, what is 4 RCPs. But if you want to really use this, you would be able to figure out probably if you went to the World Clim website, because there's the same acronyms. But you can also certainly download it from there. So download data, future conditions. Let's go to the 5 minutes resolution. And so what I used was this one here, which you can hardly see, but HD 26 is the RCP. So I was using 85, so that's the one I had actually. So this one, HD 85 BI 50, so 2050s or 2070s, and so you could reconstruct it, but it's probably easiest at this point to why would you could just download them from here and use them that way. But yes, the idea is that I will document that soon. The important thing is though they're available, and so if you download them here, you have to unzip them, and then you have to, which is not so easy. Actually, maybe let's do that. Let's just download some files and let's see if we can work out how that works. So I'll take a low resolution, 10 minutes, so that goes relatively quickly. Let's do 2070. Let's do the bioclimatics again for this model. Doesn't really matter. See if it will download. Okay, it's downloading. Yes, question? Somebody here? Yeah.
It's a different question. Is it easily to get greenness data the same way?
What kind of data?
Greenness data.
Greenness, like ocean greenness or just or land greenness. Yeah, well, in principle, yes. There's different sources. But this is typically kind of a MODIS or satellite product. So let's look at that as well. Let's just look at that. Let's find one. So here's this zip file that I downloaded. All these files in there. So let's unzip these. I'll put it in temp. New folder. Come on. Try again. New. CMIP5. I'll put them in there. Okay, so here are my downloaded files. Now, how do I use those? Well, let's just, one way to start would be this way. Let's see what's, okay, you know this goes wrong. Why does it go wrong? If you all seen this, error, /c is an unrecognized escape in character string starting, blah, blah. What the hell does that mean? Yeah, you probably know. Go ahead, tell me.
Wrong slash.
You have a wrong slash. What is the wrong slash? I mean.
Backslash.
Oh, so the backslash is wrong, but why? Why is it? And why is this one wrong and that one is not wrong?
Because how you send a different has a special meaning in the language.
Has a special meaning, right? So this slash is the escape character. This combined with another character has a special meaning. So it's used to indicate that this is an N, but this is escape N and it has a special meaning. What does escape N mean?
Following line?
New line. Return. Hard return. Escape T. Very common. Tabulate. And so that's sort of the ASCII code to have some of these word processing symbols, if you like, or tricks in a text file. Now, and so this is wrong, but this is fine. But now this one, unrecognized. /c doesn't mean anything. So that's what it's saying. This I understand because what we had C colon tab EMP unknown character. And so what do we do? Two things you can do. Escape the escape. You say, well, escape slash means actually I want a slash. Now it's fine. Right? So escape, escape. Now it means that because the escape is escaped, it no longer means escape, it just means slash. Right? Okay. On Linux, you always use forward slashes, and that also works. Okay, so these are the files we downloaded. This was the model abbreviation, RCP, BioClim, 2050, and then one, da-da-da-da. So why are they in this order? Well, they are in this order because this is the alphabetical order. Now, the alphabetical order doesn't really help us very much, right? Because this is alphabetic. 1, 1, 0, 1, 1, 1, 2, and eventually get to 3. Alphabetic is not 1, 2, 3 if you have also a 10 in there. And that's, I would typically want to have these in order. So that's difficult because you would say, well, okay, I have these files here. I could do sort F, but they are already sorted. So how can we sort these so that we can actually get them in the order we want them? I would like to have them 1, 2, 3, 4, 5, and then ending with 19. Anyone? How much you sort this?
You extract the number of the string and then you sort it with it?
Yeah, you need to extract the number from the string. So how do we do that? String cut or something, yeah. Well, but essentially that's what it is. I mean, that's good. I mean, it's very nice you were able to. The first step, but if you're not used to this type of work, if you're used to GUIs and Excel, you have to learn how to think systematically. And that's exactly how you think about it. Okay, well, somehow you have to get that number, and somehow you have to cut it out. Now, string cut is not an actual function, but it doesn't matter. You have it's something like that. Let's see. What can we do? Well, one way to think about it is there's some. It's not so easy. You cannot say, well, so it's 1, 2, 3, 4, 5, 6, 7, 8. You could say, well, cut 9 and 10. Well, sometimes it's 9, sometimes it's 10. But at least you can cut off the first 8 characters and get 9 and 10, and then maybe get rid of the dots. That may be one way. So we could say substring F 9 to 10. It's probably wrong, but let's see what that does. Actually right. And now this will work actually, because I'll just say, well, what about S integer? That was easy. Okay, so now this is nice to have. So we have these integers, and let's call that I. And we really want, what we want to get is, of course, this. Well, we want the file names to sort like this. So how do you do that? Still not quite there. We sort of have this now, but now we need to sort this by It's not so easy, or is it? Wow. How would you do that? It's a really interesting magical formula. This is odd how this works. Maybe there's different ways, but the way I would do it is odd. So you can say, well, O.
Give it a name and
Okay.
transform that in an object and then use it to order.
Yeah, well, so I've given it a name, so it's I. So how do I use this to order those?
You put F, how do you say brackets, I?
Fi. Nope, 1, 18, 19. So if you do that, you get the first and then the 10th and the 11th. So we had, F this way. So you get the first and then the 10th, but the 10th is this one. But what we need is this, we need this one. We need the 12th. That's close, but what's that? In sort I, yeah, no, because if you do in sort I, well, they'll all be in there. I mean, it's interesting. I in sort I. Is that what you say? That's an odd thing to say because all i's are, of course, in sort I. So that won't change anything. So if you say I in I essentially, that's all true if you sort it or not. So I in I, so you could say is I in 1, 2, 3. Well, some are and some are not.
Decreasing, adding the argument decreasing?
I'll show it. So what you use is the order function. Order I. And you get this. And it works very odd. But now if you do F order I, padam. Okay, so it's hard to follow how that works. And so But the trick is here. So order I is sort of how it ought to be sorted. So if you say, so order I is 1/12. And if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is the 2. So basically it says, if you want to order I, these are the indices that you need to use. So you first want I1, then I12, then I13, etc. So if you do I order I, you get the same as sort I. So order I tells us how you need to, what you need to change in the order of I to sort I. And given that I has these numbers that came from F, it needs to be sorted the same way. So now we know how to sort F because we figured out how to sort I by getting this order I. And so it's a really odd, nice little trick, but it can be very confusing because you see these order I numbers and I always mix up what they actually mean. But F order I sorts them. Okay, that's great. So now I assigned it back to F. Now I have these file names. How did I get them in the first place? Let's remember that. It was important. So we got them here. And then I sorted them this way. Now,
that's interesting because sort I decreasing through would order I, but wouldn't order F.
no. No, why would it? Because you're touching I, not F, right? It doesn't do anything to F.
But by putting I, wouldn't we be using the indexes of F to order F? I mean,
What would you type?
I would type I is sort F.
I is sort F. Well, then you just get but then you just get F back.
Actually, I use a different words here. I will first make the list of the files, okay, and then I use as integer substring for having a.
So that's I.
So having the numbers, that's I, and then I will sort I decreasing false. So I will get.
That's ref sort I. But then it's just the opposite.
No. Actually, I would put sort decreasing false.
Is that the same thing?
Is not. I had an ascending order.
Oh, okay, so that's just sort I then.
That's it.
No, because now you just have one. Now if you use I, you just get exactly the same order what you already have, because you say F1, F2, F3, F4, and that's what you already have. You don't change anything. Right? If you do F I at this point, that's exactly what F is, because you're getting F1, F2, F3 in the same order as you already had them. So it doesn't change the thing. That's why order I is interesting, because that is, now these indices are different. Oh, you're going to get F1, F12, F13, and then, so you get F1, 2, 3, 4, 5, up, and then you get 11, 12, etc. So that's why this one works. All right, so this one works. Let's leave it at that. So I'll just, for simplicity, I'll set my working directory. Well, let's not do that. So we have these files in order. And now, how do we make a raster object that we can work with? What would be a function before that? So now we have the file names, but we don't have an object yet that we, these are these future climate data, and let's say we want to extract some values or whatever we want to do. What stack? These are multiple files. You want a single object, so we say stack f. So s equals stack f. Doesn't work. Does not exist in the file system and is not recognized as a support dataset name. Well, I think that should be or, but well, and is fine too, I suppose. It doesn't exist and we don't recognize it either. Why is that? File exists.
We have not in the, it's in the right.
We're not in that folder, right? So that these files, I got them by saying list files in this folder. I didn't say full names is true, where you would get the file names with the folder name appended to it. And so it thinks it's in my current working directory, which is get working directory. It thinks it's here. Well, there's different ways you can work with that. You could change your working directory. I typically don't like to do that. And so what I would do now is just say paste 0. The folder where it came from, which is this one. Paste means, it paused. Glue together. In this case, not the same paste as in copy and paste. So let's call it FF. And so now FF are the full file names with a path where they are. And so stack FF. Now something is working, and S is our data set. So this is how you would do it, by downloading them manually. And supposedly, let's see, plot S1. This should plot the first layer. There we go. Okay, you want vegetation data, right? Or greenness. So let's see. Greenness data. The greenness of monitoring methods. Okay, let's do something else. Let's do Ndvi. So that's a technical term, normalized differential vegetation index. Data, let's see, download. Let's look at this one. Let's open this one. Not sure anyone knows a nice simple source, but well, let's just see how far we get. University of Maryland is not home today. Oh, go back. Come on. What's going on? Clark's Labs have one. Okay, here, 16-day L3 global 215 meters. mod 13Q1. Anyone understands this stuff? Any Modis users? There are some, because people complained to me that Modis was too slow with the raster package. So now speak up. Not paying attention. Anyone else? Well, what this all means, vegetation indices, 16-day, L3 global, 250 meters, mod 13Q1. I mean, it's kind of acadabra. Level 3. It was level 3.
You know, if it's satellite, it's kind of resolution, I think.
Anyone else? Level 3? Yeah, well, the way Modis is processing level, that's what it is. Yeah, so Modis is the sensor on 2 satellites, Terra and Aqua. They've been there in orbit for 12 years now or so. So every day they cover the whole world with different sensors, really. 250 meter resolution, 500 meter resolution, 1 kilometer resolution, depending on the bandwidth. So 250 meter tells us the spatial resolution. And then there's different levels of processing. You have the raw data, and then they process it, they geocorrect it, and do some things with it, and so forth. So L3 is sort of the third level of processing because it's already a derived product. I think that's one of the reasons it's in L3. It's no longer the raw reflectance data that was actually measured by the sensor. It's now some computed quantity vegetation index. 16-day meaning it's not daily. It's a 16-day something. Maximum, average? Probably the maximum. In many places, Modis comes over every day, but you're lucky if you find one day, like in Bergen, you're lucky if you find a good day without clouds. And so typically you take for every 2 weeks, 16 days, half a month period, you take the max for the best conditions. That's your reading. That's how you would do it, Ndvi. And I'm sure that's all explained here.
Like in the third paragraph.
So certain things at least, yeah. All right, so that's nice. So this data exists. Now where do we get it? It doesn't tell us. Data access. NASA is just terrible for this stuff. It's just so complicated. Each time you have to relearn it. But let's see if there's a simple one where you can just download it without having to set up an account and everything. Of course, data access helps us. The data pool, online archive. That's what we could try. Meanwhile, there's also this one, which again points to Maryland, which was offline, it seems. Let's see if it... Land cover data. Okay, let's see how the data pool is working. Okay, download via HTTP. Okay, well, let's do Aster, another satellite, higher resolution, Modis Aqua, Modis Terra. So the satellites are called Aqua and Terra. They have the same instrument, Modis instrument on it. Well, it's a different instrument, but it's the same specifications. Combined, we don't really care which one it is. Okay, there we go. Now what? What are these directories? Well, these are these different products. So which one did we want to have? 13Q1. It's not there. They have 12C1, 12Q1, 20. We could try 12C1, but I don't know what it is. Let's see, 12C1. But let's just have a look at it. Okay, now we have these numbers. Any idea what those mean? You could probably guess it, right? 2012 to the 11. So those are years. So this is just one yearly thing. But it's not what we wanted, so let's not do that. I'll leave it at that, actually. I don't know if a simple source, the short of it is, yes, it's there. It takes a while to find it. In this example where I was going, now we get HDF format, which is actually a problem. RGDAL, the standard RGDAL for Windows doesn't read that, so you have to use some other tools to transform that to another file format. So Modis is tricky, but it's certainly there, and I'll try to spend some time to find something, but it's probably will take too long for just to do this as a group. Yeah, so data, it's hard to give a general statement. There's a lot of data out there. There's an incredible amount of data out there. It's surprising how poorly organized it is. You think, well, if there could be so much efficiency would be gained if that were easier available, but it isn't.
It's said that it has to be authorized for certain people. So is that the use of it?
Out here? No, that's just. Maybe I first have to turn down the camera before I respond to that. No, that's just the boilerplate statement they always put. It's like these emails that people send to mailing lists, say that this is only for intended recipients, and if you're not the intended recipient, you should delete this, and if you don't do that, we will prosecute to the full extent the law and da 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 da. This is just to say, well, who knows? But we can always try to get you. But yeah, this is the United States. You know, they like legal thing. So disciplinary action in criminal prosecution. At least the nice thing here, they actually specify that you're consenting to complete monitoring with no expectation of privacy. They typically don't say that in everything else we do. So
no, that's just a click ahead, isn't it?
Here at least they say so. Any questions about data? It's a bit of a fuzzy subject, so it's hard to give any definite answers. Another example. What data would you like to have? What if I have? No, that's too easy. That's the thing, because I can show you things that I know are easy to do, but that's why. And then you go home. We say, well, yeah, that was easy, but now I want. What do you want? Any croplands? Croplands. Yeah. There's some. There's a couple sources, but that's cropland data, spatial data. So here's one, or crops. Assessing the spatial distribution of crops. Free spatial data, Ndvi GIS, interesting. Here's one. Let's look at this one. There's another big one that somehow doesn't show up, which is interesting. Raman Kuti has made a lot of these data sets. Somehow, you need to know that, it seems. Oh. And map spam doesn't work today. Let's see. I know spam crop maps is also one. Yeah, that's this one. Somehow. We are in the data. The data sets are down. Okay, there's Neverman Kuti data. This is data. Okay, global cropland and pasture data. New from 2007. Harvest area and yields for 175 crops. Which one do you prefer? Just a cropland or specific crops? Let's say cropland. There's there. NetCDF. Oof. Anyone know what that is? NetCDF. Okay, you got global crop and pasture 1700 2007. Half degree netcdf.zip. Yeah. Well. Yes, and actually, in the raster packages, that's pretty much automated, so you can just treat it as any raster data set. That's nice to get up this. So netcdf is a format that's used particularly in climatology. It's a generic file format you can use to store any kind of array of any dimension. So matrix or three-dimensional, four-dimensional arrays. So the climatologists like it because you can, for example, these climate models, you'll have spatial data, and then you have the atmosphere, so you have different heights, and then you have time. So you have a lot of dimensions, and you have different variables, and NetCDF is a very nice file format to store that. And some other groups also use it. But it took a long time for the sort of the GIS community to deal with that. ArcGIS now also, I think, can read it. So R has the NetCDF, the NCDF package, and then the raster package uses that to just treat this as any other spatial data set. So let's see if that's going to work. Open this. Maybe you can even animate this and look at the changes in cropland over time. That'd be nice. Where do I put this? Let's put it again in ctemp. Or just here, and will allow me continue. Okay, so I can actually open it. So there's the Intel as a little viewer that allows you to look at it directly. But let's just say, so this is a brick because it's a single file, multiple layers, not stack. That'd be inefficient.nc, I think it was. Meanwhile, we can look at it here. So you can inspect sort of what's in there with some of these tools: global historical land cover data, sources, no history, Gregorian calendar. So it tells us how time is kept and where we start, and if you have leap years or things like that. Use certain conventions. Here's the time, 1700, 1701, so that's years. All the latitudes, all the longitudes. Anyway, that's all in that file, but we don't need to know that because we just have this break now, and we can do a plot B1. It's kind of hard to see these colors. So basically it says in 1700 that really, Western Europe was, and India and parts of China and Yangtze area and Nigeria, a lot of cropland. These are big guesses, right? But that's what they figured, and very little in South America. So let's actually we could compare that with. So we have 308 layers. So let's look at the last one. Let's make a new one, new window, so we can put it next to each other. Brazil's clearly something happened there, and the United States is pretty spectacular as well. Nigeria is pretty stable according to I mean, there's more, but not that much more, so that seems a bit odd to me. I don't think population density was nearly as much, it wasn't nearly as much as it is now, so I'm not so sure how good that is. Let's see if we can animate this. There is a function, but I forget how it works. Let's see. Animate X. All right. And what does it create? Maybe it just draws the movie like that. Let's see. I truly don't quite remember, but that shouldn't matter. Animate B. Error. Oh. Well, I guess it's not going to work. Why would it be, though? Well, not working. Strange, but maybe I can try. I'll aggregate it, make it a bit smaller. Takes a little while to aggregate it because there's all these. Oh, gee, same problem. Maybe I've been doing too many things. I'm just going to close and open up again. Library raster. Animate B. Who knows? I doubt it, but you never know. Well, clearly that's not working. Okay, I'm sure it's possible. This way, simple, regular, B, 10,000. I'll make a very small version of it and see if we can animate it then. Something not working. Oh well. We'll zip it up. We got the data. At least we got the data. There seems to be something other thing that's odd with it. I'm not sure. What?
A possible way might be to animate, to make a GIF of the.
Well, that's what this would do. That's what I mean. Well, there's two things this can do. This would just animate it live, but there's also a way to write it to a GIF. So you can save it and put it in your PowerPoint. You know, so I use that function to create. Let's see, I have some here. G Drive, no, in Docs, PowerPoint. Here. So again, with all this space-time data, it gets very hard to visualize that. You know, how do you show that? That was yesterday's. I think my computer's getting tired. Here we start. Oh, I already showed one animation yesterday, actually. But because you asked for a cropland, well, here's a couple. Something not going right.
Sorry, I just have a question. Are you saving the codes, or because for me it's really difficult to document what you're doing because it's like the.
Yeah, well, I don't really expect you to be documenting it. I mean, you have the documentation. A lot of the things I talk about are in there. I really think what I would try to do is to listen and to follow the concepts and the thinking and the logic, not any particular command, because they are really in these handouts anyway. It provides some more context. But I will try to save them anyway in the future. The ones I had, I just thrown away. But I think it's really not too worthwhile to write them down, because you get all these little code snippets. I mean, like the sorting I was doing. Yeah, there's all kinds of little tricks. But you know, when I said like the important thing is that you understand sort of certain steps you have to take, and that's really where I feel you have to get from what I talk about. So here's one animation. Here's another one. The really model output. But I had some here that I thought I would show, but I forget where they are now. Here's another. This is what's this more a cropland example. This is corn in the United States from 1870 to 2012 or so. So yeah, you can look at cropland over time and animate it and analyze it. Yeah, so data is very multidimensional, so it's hard to make many general statements about it. But all right, I think any questions about data issues? So we talked a bit about these boundaries, and economists will often work with boundaries and census type data and try to link those, and that's troublesome with these names that don't match. It just takes time to do it. Another problem with these boundaries that I was showing for France is that they change over time, so very often you get data for a set of, say, provinces, and then you have maps of the provinces, but it doesn't match because there was a change. You go into QGIS and try to fix that, maybe by drawing new boundaries in, looking at Wikipedia, stuff like that.
It's for raster grid, or raster stack, but how would you put this in a raster? I mean, this seems to have more than.
Oh, these are actually. That's true. The animate function I showed was for breaks. This is actually spatial points, and probably done with the animate package, or just with a loop, some kind of a loop where you just plot one after the other. Yeah. Yeah, it's a good point. This is a different. The other ones, yes, but this was a different example. I'm going to restart here. Okay, I'll come around again. See how far we're getting before lunch, so we can think about the afternoon. So in the afternoon I want to talk about. Oh well, downscaling I didn't talk about. That was other question. So climate data. Climate data is something that Tom Hengel is also working on. He's working on a project to get high resolution, high spatial temporal resolution weather data. So historically there's always been the sort of a trade-off. Either you had high temporal resolution like weather stations, you have daily data or even hourly data, but only for stations. And then you have raster data. But typically, then initially there were very large areas, maybe half degree. Then there's worldclim, which is high spatial resolution but very low temporal resolution, because you only have climate averages. So this is trade-off of what you had available between time and space, and increasingly, right? So you either had time or you had space. If this is time, can you even see this? But increasingly we're going there. But it's also a difficult area to navigate, where you have all kinds of different products. But the CMIP5 data we're showing, so there is very high spatial resolution, downscaled future climate data on the WorldClim website you can use in this context. That's probably as good as you need in most cases. It's just some average for 2050, 2070. It's for more complex models where you really want to simulate some daily weather data for some ecological response process model or so, where things are trickier and where it's even there it may be unclear whether you really want daily data or just want to simulate daily data out of monthly data or approximate things. And there's all kinds of opportunities or different routes people are taking. A lot of literature about all kinds of different examples, but. So I would say, a lot of downscaling that exists, typically you don't need it, need to do it yourself anymore. I would hope.